Good day, students. On behalf of the teachers in Mathematics 8, I welcome you back to our lesson on factoring polynomials. For this week's lesson, we shall be factoring polynomials that are perfect square trinomials, quadratic trinomials, and polynomials that could be factored by grouping. For the fourth type of factoring, we first need to find out if the polynomial is a perfect square trinomial using the following conditions. Condition 1. Do we have a trinomial? X squared plus 2xy plus y squared and x squared minus 2xy plus y squared both have 3 terms each. Therefore, they are trinomials. Second condition. The first term and the last term must be perfect squares. Recall that a variable with an even exponent is a perfect square. Thus, x squared and y squared are both perfect squares. And lastly, the middle term must be twice the square root of the first term and the square root of the last term. The middle term could either be positive or negative. Thus, these two polynomials here are perfect square trinomials. To factor perfect square trinomials, we follow this pattern. First, we extract the square root of the first term. The square root of x squared is x. Then, extract the square root of the last term. The square root of y squared is y. And separate the square roots using the sign of the middle term. So we have here positive and positive. This can be rewritten as the quantity x plus y squared. Let's do the same in the second perfect square trinomial. We extract the square root of x squared. The square root of x squared is x. Then, extract the square root of the last term. The square root of y squared is y. And separate these using the sign of the middle term of the perfect square trinomial. So we have here negative. This can be rewritten as the quantity x minus y squared. Here now is the pattern in factoring perfect square trinomials. Let's find out if the polynomial x squared plus 6x plus 9 is a perfect square trinomial and factor it out if it is. Is the polynomial a trinomial? Yes, it has 3 terms. Is the first term a perfect square? Yes. What is its square root? The square root of x squared is x. What about 9, the last term? Is it a perfect square? Yes, and its square root is 3. And lastly, is the middle term 6x twice the product of x and 3? Let's find out. X times 3 is 3x. Double that would be 6x. Therefore, the given polynomial is a perfect square trinomial. Let us now write the factored form of the given polynomial. We have here the square root of the first term, x, the square root of the last term, 3, and the sign of the middle term, positive. Or we can rewrite that as the square root of x plus 3 squared. Let's find out whether the factors we obtained are correct using the FOIL method. Let us multiply the quantity x plus 3 and the quantity x plus 3. First terms, x times x equals x squared. Outer terms, x times 3 equals 3x. Inner terms, 3 times x equals 3x. And last terms, 3 times 3 equals 9. The two terms here are similar terms. Therefore, we can combine them. We'll be having x squared plus 6x plus 9. Since the product we obtained in the checking is the same with the original polynomial, therefore, we obtain the correct factored form of x squared plus 6x plus 9, which is the quantity x plus 3 times the quantity x plus 3, or the quantity x plus 3 squared. Let's find out if the given trinomial is a perfect square. The first term, 49x squared, is a perfect square, and its square root is 7x. The last term, 1, is a perfect square. Its square root is 1. If we multiply the product of 7x and 1 by 2, we obtain the middle term, which is 14x. Therefore, we have here a perfect square trinomial. We now write the factored form. We have here the square root of the first term, 7x, the square root of the last term, 1, and we follow the sign of the middle term, negative. We can rewrite that as the quantity 7x minus 1 squared. Let us do the checking using the factor 7x minus 1, the quantity squared. Let us use the special product, the square of a binomial. How do we do that? We square the first term. The square of 7x is 49x squared. We square 1. The square of 1 is 1. We multiply the two terms, 7x times negative 1, and then double the product. That would be negative 14x. You'll see that the product we obtained in the checking is the same with the given original polynomial. Therefore, we have obtained the correct factored form of 49x squared minus 14x plus 1, which is the quantity 7x minus 1 squared. But what if the given trinomial is not a perfect square trinomial? In this case, for the fifth type of factoring, we have the general quadratic trinomial ax squared plus bx plus c, where a equals 1, or a is greater than 1. And we now factor quadratic trinomials, where a equals 1. In this particular scenario, our goal is to find out factors of c that when added will give us a b. Let's begin with x squared plus 5x plus 4. What factors of 4 when added will give us a 5? These are 4 and 1. 4 times 1 is 4, and 4 plus 1 is 5. Based from this, we can now write the factored form of the given polynomial. Its factored form would be the quantity x plus 4 and the quantity x plus 1. We made use of plus here since both 4 and 1 are positive. Next up, number 2. M squared minus 7m plus 10. Again, we need to find out factors of 10 that when added will give negative 7. These factors are negative 2 and negative 5. Take note, negative 2 times negative 5 is 10, and negative 2 plus negative 5 is negative 7. Therefore, the factored form of the given polynomial is the quantity, take note of the variable, m minus 2 times the quantity m minus 5. For example, s squared plus 11s minus 12. What factors of negative 12 when added will give us an 11? These are 12 and negative 1. 12 times negative 1 is negative 12, and 12 plus negative 1 is 11. Thus, the factored form of the given polynomial is the quantity s plus 12 times the quantity s minus 1. And lastly, let's find out the factors of w squared minus 2w minus 24. The factors of negative 24 that when added will give us a negative 2 are negative 6 and 4. Negative 6 times 4 is negative 24, and negative 6 plus 4 equals negative 2. Therefore, the factored form of the given polynomial is the quantity w minus 6 times the quantity w plus 4. Take note that since multiplication is commutative, these factors could actually be written as the quantity x plus 1 times the quantity x plus 4. This can be rewritten as the quantity m minus 5 times the quantity m minus 2. This can be written as the quantity s minus 1 times the quantity s plus 12. And lastly, we can have here the quantity w plus 4 times the quantity w minus 6. You can check your answers using the FOIL method. Let us now factor quadratic trinomials where a is greater than 1. Take note that the factors of any quadratic trinomial is composed of two binomials. So, let us have the polynomial 3x squared plus 7x plus 4. Is it a trinomial? Yes. Is the value of a greater than 1? Yes, 3 is greater than 1. So how do we factor quadratic trinomials where a is greater than 1? Let's follow these steps. First, we need to identify the factors of the first term. In this case, the factors of 3x squared are 3x and x. These factors comprise the first terms of each binomial factor. Next, let us have the second terms of each of these binomial factors. Where do we get it? We get that from the factors of the last term, 4. Let us list all the possible factors of 4. 4 is 2 times 2. It is also equal to 1 times 4. And since multiplication is commutative, we can also have 4 times 1. Through the trial and error method, we are going to find out which of these pairs of factors, when combined with the factors of 3x squared, will yield to our middle term, 7x. So, we are just to copy 3x and x, the first terms of our binomial factors, and write 2 and 2 as the second terms of these binomial factors. Next, let us multiply the outer terms together. 3x times 2 is 6x. And the inner terms together. 2 times x is 2x. And then add the results. 6x plus 2x is equal to 8x. Is the middle term 8x? No, it is not. Therefore, this is not the correct combination. Let's proceed. What about 1 and 4? 3x plus 1 times the quantity x plus 4. Let's multiply the outer terms together. 3x times 4 is 12x. Next, the inner terms. 1 times x is x. And then add the products. 12x plus x is equal to 13x. Is the middle term of the given polynomial 13x? No, it is not. Therefore, this is not the correct combination. Let's proceed to the last pair. The quantity 3x plus 4 times the quantity x plus 1. Let's multiply the outer terms together. 3x times 1 is 3x. The inner terms together. 4 times x is 4x. And add the two products. 3x plus 4x is equal to 7x. Is 7x the middle term of the given polynomial? Yes. Therefore, we have arrived at the correct factored form of the given polynomial. The factored form of 3x squared plus 7x plus 4, therefore, is equal to the quantity 3x plus 4 times the quantity x plus 1. And since multiplication is commutative, we can rewrite these factors as the quantity x plus 1 times the quantity 3x plus 4. This now is a correct factored form of the quadratic trinomial 3x squared plus 7x plus 4. If the terms of the given polynomial do not have common factors, consider using other types of factoring techniques. If the given polynomial is composed of two terms, it might be factored by the difference of two squares or the sum or difference of two cubes. But if the polynomial is composed of three terms, consider using factoring perfect square trinomials or quadratic trinomials. But what if the given polynomial is composed of four terms, just like ax plus ay plus bx plus by? How do we factor this polynomial? We now proceed to the sixth type of factoring called factoring by grouping. In this particular scenario, ax and ay can be factored by common monomial factoring. Their common monomial factor is a. And their other factor is the quantity x plus y. In the second group, bx plus by, b is a common monomial factor. So let's factor that out. The other factor is the quantity x plus y. From the four terms in the original polynomial, we now have two terms. In the binomial, the quantity x plus y is a common factor. To get the other factor, all we need to do is divide each of these terms by the common factor, the quantity x plus y. Let's do that. A times the quantity x plus y divided by the quantity x plus y equals a. B times the quantity x plus y divided by the quantity x plus y equals b. Thus, the other factor is the quantity a plus b. Therefore, the factored form of the polynomial ax plus ay plus bx plus by is equal to the quantity x plus y times the quantity a plus b. Let's factor the polynomial 2x minus 5y plus xy minus 10. The first thing that we need to consider here is to regroup the terms which have a common monomial factor. Let's find out. 2x minus 5y. Do they have a common monomial factor aside from 1? None. What about negative 5y and xy? Do they have a common monomial factor aside from 1? Yes, it is y. Therefore, these two terms can be grouped together. The remaining terms, 2x and negative 10, can be grouped together since they have a common monomial factor aside from 1, which is 2. Therefore, we have the grouping 2x minus 10. This is one group, plus the quantity negative 5y plus xy. This is the second group. Now, let us factor the first group by the common monomial factoring. Again, 2 is a common monomial factor. The other factor is obtained by dividing 2x and negative 10 by the common monomial factor 2. The other factor, therefore, is 2x divided by 2, x. Negative 10 divided by 2 is negative 5. what about the other factor here? The common factor to them is y. The other factor is obtained by dividing each of the terms by the common monomial factor y. Negative 5y divided by y is negative 5. Xy divided by y is x. Now, since addition is commutative, we can actually rewrite this as the quantity x minus 5. And so, we shall be having 2 times the quantity x minus 5 plus y times the quantity x minus 5. Again, the quantity x minus 5 is a common factor to these terms. Therefore, we can factor it out. We have the quantity x minus 5. To get the other factor, we divide each of these terms by the common factor, the quantity x minus 5. And so we have 2 times the quantity x minus 5 divided by the quantity x minus 5 is 2. Y times the quantity x minus 5 divided by the quantity x minus 5 is y. Since addition is commutative, we can rewrite the factored form as the quantity x minus 5 times the quantity y plus 2. And since multiplication is commutative, there is another way of writing the factored form of the polynomial. That would be the quantity y plus 2 times the quantity x minus 5. To check that these are the correct factors of the given polynomial, you apply the FOIL method. Congratulations, students! Another set of treasures has been added to your learning box. See you again next time for a new set of lessons.